Hello everybody. In this video, we're going to be talking about effective, or what we call RMS value. And to start off, let's start off with this question right here. The amplitude of the voltage available in the power outlet in your home is. So the question is, what is the value? A, 110 volts, B, 120 volts, C, 170 volts, or D, 210 volts. So what I did was I went downstairs, went to my nearest power outlet, and also took one of my multimeters and then measured the value of the power outlet. And it turns out that it is 120 volts. Then what I did was that I looked at the answer, and then I realized that the amplitude was not 120 volts. It was 170. So now I have a question. Why is it 170? Why is the answer 170, but the multimeter shows us 120? And what I found out was that 120 was not the amplitude. The multimeter was not showing the value of the amplitude. What it was actually showing was the effective value. So the effective value of a periodic current is the DC current that delivers the same average power to a resistor as a periodic current. That is what the effective value was. So therefore, the value, 120 volts, was delivering the same average power to a resistor as the periodic current. Now that periodic current would come in an AC circuit. And that periodic current, as well as the periodic voltage, because together it will produce an alternating value, that would essentially be our amplitude, which is 170 volts. Now this may sound confusing, but I'm going to break it down to you by drawing two circuits. So I'm going to draw one circuit right here, and then the second circuit. DC and AC. So we have our current flowing here, and then a current flowing here. And I'm going to draw one right here because it's bidirectional, it's AC. So our DC circuit, we would essentially have a current that is flowing. And that current would be an effective value. Now we have our current here, and an AC current. That AC current would be bidirectional, so we have this wave to show that it can go clockwise and counterclockwise. And what I've said before is that of the effective value, that our DC current, our effective current, would deliver the same average power to a resistor as the periodic current. So this is our periodic current and our effective current. And our average power here and our average power here would be equal to one another. So now let's understand how can we translate that effective current to our alternating current. What is the relation with each other? Our alternating current is very simple. It is simply equal to the effective current multiplied by square root of 2. And that's why we have that knowledge of root mean square, right? So effective value is equal to root mean square. I'm sorry I didn't write down this because it is pretty important, but there's a root right here, comes from this sign, right? square root. So our effective value is equal to our alternating current is equal to our effective value multiplied by square root of 2. So looking back to our question, the amplitude of the voltage available in the power outlet in your home is, and what I've shown before is that the multimeter showed us 120 volts. And since that 120 volts is our effective value, what we need to do is multiply that by square root of 2, and that would give us our amplitude. And our amplitude would be approximately 170 volts. So the answer is actually this one. So I hope you guys will enjoy this video and understand what is effective value versus our amplitude value. Thank you so much for watching, and I'll see you next time.